Hello, everyone. So today we are going to talk about 2D plots in MATLAB. Okay, so these are one of the most important things, basic things that you do for creating reports, writing about assignments, and so on. And so I thought that in probably one long video lecture, I'll talk about important things about 2D plots in MATLAB. So let's start with the scripts that we talked about last time. So here I create a script, and then in this script, I create the plot of a simple function. So let's say I have some values of x between 0 to 2 pi, correct? So I say between 0 and 2 pi, I want 100 values linearly spaced, and then I want my function to be maybe sine of x squared, maybe, correct? So here I'm raising each element in vector x to the power 2 and then taking sine of it. And then the simple command that I can use in MATLAB for 2D plots is called plot. So I say plot x as horizontal and y as vertical axis, and then run, right? That's the very simplest thing you can do. So I call it plot 2D demo, and I run. And there we go. That's your function, right? That you can see. A sine function with increasing frequency. Now, let me make the number of data points a little bit bigger so that you can see the behavior of it a little bit better. And that's your function. Good. Now, here, let's talk about a bunch of important things. One, you don't really have infinite number of points, correct? Here, they are all lines, so you might infer that here I have an infinite number of points. You don't. You only have about 1,000 data points. That's all you have. But here, where are those 1,000 data points? Why don't I see data points? Why I see instead a continuous curve? Well, because MATLAB default is if you do not tell it how to connect those points together, or whether it should connect them, those points together, or not at all, MATLAB decides to connect them using blue lines. So what MATLAB does between each one of those 2 points, MATLAB, so here, if you go to this plot and if you click on this guy here, which is called data tips, if you click on that and then click anywhere on this curve, it gives you the value of x and y of that location. And then if you use the mouse left key and drag, or use your up and down arrow on your keyboard, you clearly see your data points are jumping, correct? This black point on the curve does not move continuously. It jumps from one point to the next. And those points it jumps on are those 1,000 points that you used. So what is it doing really? It is connecting each one of those 2 points, consecutive points, using a blue line, and it creates this kind of continuous curve for you, although it's not perfectly continuous, but you can be tricked to believe that it is like infinite number of data points. It's not. So what if I want to show on the data points as well as these lines connecting them? Can I do that? Sure. Now what you need is called marker. So here now inside quotation mark, you have to tell the shape of the marker. And so if I say circle, means at each one of those 1,000 points, use a circle. If I don't provide any other thing, then it will only show 1,000 circles and not connected. You see? So those circles are at the location of each one of them as one of those 1,000 points. And you see they are not connected to each other. So now you don't see any continuity here. If I want to continue connect them together, now I add a dash, which means now connect your markers with a solid line. So now if you do it, not only you have the markers, you also have what? You also have a solid line, blue line to connect them. And you can change the shape of the marker. Let's say if you use a caret instead of a circle, then you can make them a triangle. Okay? Now at each data point, you have a triangle. Or if you use H, correct? Now you have a hexagram at each location, and you can use this plus and minus, drag a window around them and look at them. Correct? So you can use this plus and minus to zoom in and zoom out, and you can use this hand to pan, move the curve around. And if you click on minus a few times, you go back to the regular zoom. So we'll learn also about negative, positive, pan, and data cursor, or data tips, we call it. So I can change the shape of my markers to a specific number of predefined shapes. And I can also tell MATLAB whether to connect them or not. If I use a dash line, it means connect. A simple dash line means connect them. If I use two dash lines, it means now connect them really with non-solid connections, but with dash connections. So now if you look, the connections are dash lines, not solid lines. Okay, or maybe I want to connect them with dash dotted lines, so I say dash dotted line. So the way they are connected, I will decide. Again, there are a specific number of predetermined type of connections, but you clearly can see that here. Or I want them to just be connected with a bunch of dots. So if I say dots, dots, what do you think would happen? It doesn't like it. That's not what you want. If you want dot, dot connection, that's not two horizontal dots. That's what? That's a column operator. Okay, so you have to know what to type in that, what we call line properties. Okay, what are the shapes? What are the connectors and so on. Now, if I want to change the color of them, so instead of blue, I want them to be green. So I use G for green, correct? So now, you see, now the color is green. If I want them red, then I type in red, and maybe I use a X, correct? So you can change the color, you can change the shape of the marker, the way they are connected together. You can make them thin or thick, correct? So I can say line width and say 2 pixels instead of 1 pixel default, or half a pixel or whatever. So you can change the thickness. You see, now they're clearly thicker. So with the line width command, which should be spelled like this in single quotation and the number of pixels, I can change that. Now let's make it back to a circle. So you see the circles are now thick circles, and they are hollow circles, as you can see, right? But the edge of them is red because I said red. Now, what about the interior of them? Do you want to fill those circles or left them hollow with white? If I want to fill them with red color, then I say marker face color, and then say that is also red. Okay, now means fill the interior of them with red as well. And now if you look, your marker points are filled with red. Okay, if I don't like both of them to be the same, I say maybe fill the interior with blue. Good. So it's up to me to decide. If I want the edge of it to be different than this red, I can do that as well. So I don't specify that here, but I come here and I say marker edge color. That's the same as what I specified here. What about marker edge color? I want that to be black, and black is K. So the edge of it black, the interior of it is blue. And there we go. See? So you have this what we call line properties that you can specify: marker edge color, face color, the width, the connector, the shape, and so on and so forth. By the way, if one of your lines of code is long, because we can add a lot more options to this, one of your lines is so long that you have to move this guy left and right to see it, you can continue the rest of your line in the next, this rest of your code, rest of your command in the next line. So let's say from this point on, I want to bring it to the next line. So here I use the 3 dot operator. 1, 2, 3 has to be exactly 3, and then it go blue. Blue means they are specific keywords. And now when I enter, it's not like the command is really not working. It is. It's just broken into 2 lines. So you can always use dot, 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 and continue the rest of your line command in the next line, in a new line, and it works just fine. Okay, so you clearly see these line properties. Now, should I remember all of this? Should I memorize them and so on? No. Well, here I show you. So if you want, these are the specific markers that you can have. X dot star or asterisk, circle, plus sign. If you say D or diamond, you can say S for square. You can have different types of triangles using V, caret, bigger than, less than, P for pentagram, H for hexagram, none or doing nothing for no marker. The colors, the specific colors you have, if you want one single letter to represent the whole color, red for R for red, G for green, B for blue, C for cyan, M for magenta, Y for yellow, K for black, W for white. And the connectors are single dash line is solid, double dash line is just dash line, column is dotted line, and then you have dash dotted line, which I showed you. So here, these are important line specifications that I mentioned for you. Now, let's take it to one higher level for you. So let's say I want them to be like diamond, right? As you can see here. Now, I do not want the interior color of it or the exterior color of it to be black, for example. I want it to be a different color, but I do not want that color to be any of these colors in this table. What if I want orange? Well, orange does not have a specific letter allocated to it. Can I make it orange or gray or any other color that is not one of these 8 major colors? Can I do that? Yes. The way to go about it is, or maybe a random color even. How can I do that? Well, I'll show you. If you want, instead of providing a single letter for that color, or here, you might want to use the command color. And instead of, so color is just the edge color, but instead of providing the letter, you have to provide 3 values here. And those 3 values are R, G, and B values of that specific color, red, green, blue values of that color. So let's say I want the color to be orange. All you need is to Google the RGB values for orange. And if you look at them, you'll find that the RGB values for orange are, for example, let's go to Google and say orange RGB values. And you'll see that orange is about 255, 165, and 0. Now here, these numbers are for unsigned integer with 8 bits, uint8 format. The numbers you provide in MATLAB command should all be between 0 and 1, not between 0 to 255. So if you want to specify those numbers in MATLAB, you have to convert all of these numbers to anywhere between 0 to 1. In other words, you have to normalize this vector, 255, 165, and 0. So what you need is this divided by the max to make all numbers between 0 and 1. Then you're good. Okay? So this number should be 1, complete red. This one should be 165 divided by 255, and this number, blue component, should be 0. These R, G, and B values are for the color orange. And that means change the edge color of the marker to orange, not to black or blue or red or predefined colors. So now you can see that, right? It's very obvious. Okay, so one way is to use RGB, or the only way actually, if it's not one of those 8 predefined colors. Now, what if it's random? You want the color each time you run this code to be a new color. Can you do that? Yes. Since these are 3 numbers, RGB values, and they are between 0 and 1, if you want them to be replaced with random, you say rand of 3 and 1. You know, the rand command in MATLAB generates random numbers between 0 to 1, and you say, how many of them do I need? 3. Now your color is going to be a random color each time. Look, I run it this time. The color is almost black, correct? The edge color. Run it one more time. Now it's yellow. Run it one more time. Again, yellow, kind of yellow, the same as the previous one. Now this is kind of reddish or very red, purple, right? So if you want, correct, you can have some fun and generate a new type of marker color each time that you run this. You see? Quite beautiful, isn't it? Okay, so, but if you want to randomize the shape of the markers, you cannot use a random generator like this. You have to use if commands. Say, generate a random number between, let's say, 0 to 10. Let's say there are 10 predefined markers in MATLAB. If the random number you generated is 1, use square. If it's 2, use circle. If it's 3, use a diamond. Okay, so you cannot directly use the random number to change the shape of the marker or the way the connectors are connected, the markers are connected. You have to use if command, and we'll do that later. Okay, so it's not as simple. But anyways, these are some very basics that I wanted you to know about very basic plot command. Now, you created this amazing plot command. You have some control over it. Very good. But it is not still professional. Why? Because your axes, X and Y, do not have any label. You don't know what they represent. And you don't have any title for your plot, right? So now what? Let's go to the next step. Let's make it more professional. That's where the command X label comes into play. Say this is X. And then the command Y label comes into play. This is Y. And then the command title comes into play to provide a title. And say this is equal Y equals sine of X squared. Right? Now you're going to be doing it a little bit more professional. You see? Now you have a title, you have a Y label, and X label. This is way better if you want to put it in your report or assignment or something. You never want to show anybody any plot where they have no idea what they are looking at. So X label, Y label, if it's a 3D plot, we'll see later, a Z label, a title, definitely informative. Good. Now let's go to one step further. What if you want to change the ticks? What is tick? Let me show you. So if you look at the ticks here, ticks are these points where you have some numbers on the X and Y axis. So here you see they go from 0 to 6. Your values that you generated were between 0 to 2 pi. So maybe instead of going from 0 to 2 pi, 0 to 6, 1 unit at a time, you might put these ticks at 0, pi over 2, pi, 3 pi over 2, and 2 pi, or something like that. You might want to use fractions of 2 pi instead of 1, 2, 3. Right? So maybe you want to change the X ticks, these locations, and the value of them to make this plot a little bit nicer. Can I do that? Right? Can I do that? Let's take a look. So, how can I do that? Well, the way to go about it is using GCA command and then X tick labels. Okay? So, like this. So when you do this plot, you say set GCA, okay, the current graphic object that is open, that figure, and what? X tick label. I want to change the labels of X tick values to what? To a cell array. What is cell array? Please watch the video for cell arrays and structures, where the numbers in that cell array are 0, pi over 2, pi, 3 pi over 2, and 2 pi. If you want, you can use the asterisk too. Put the units on the x-axis instead of 0, 1, 2, 3, 4, 5, 6. Use these 5 ticks and show these text characters at those locations. Do you see? Now there is one caveat there here. When I created that the new ticks, the original ticks were between 0 to what? 0 to 8, I guess here, correct? So it was 0, 1, 2, 3, 4, 5, 6, 7, between 0 to 7. So I have 8 ticks. Now my ticks are still 8 ticks, but the total number of ticks I provided here are only 5. So although I expected 8 ticks, I expected what? 8 ticks, but now I'm replacing them with 5 ticks. So what about the last 3 ticks? So these are the first 5, clearly going well. But now the 3 remaining ticks that I don't have anything to replace them, it goes back and start from the beginning. Hey, I don't have anything after 2 pi, so I go back again from 0, pi over 2, and pi, and now it's messed up. Okay, so the number of ticks should also be changed to 5 instead of 8. Or if it was already 8, you make sure that the number of data points that you have here are 8 values. So either change the number of ticks or make sure this number of entries here of the cell array are the same as the original one, 8. Otherwise, it keeps repeating itself from the beginning, and you get a messed up X tick label set. How can I fix that? Well, creating 8 values maybe is not always an option, because then you have to divide this range of 0 to 2 pi into 8 minus 1 portions, or 7 portions. So each one of these should be 2 pi divided by 7. So yes, I can say 2 pi divided by 7, 2 times 2 pi divided by 7, which is correct. So it's 4 pi divided by 7. Then I have 6 pi divided by 7, dot, dot, dot. And then I have 8 pi divided by 7. And then I have 10 pi divided by 7. And 2 more, which are 12 pi divided by 7 and 14 pi divided by 7, which is 2 pi. Correct? So if I want, I can do that, and no problem. But maybe I'm not super fan of 4 pi over 7. What kind of number is that? I'm not interested. To me, pi over 2 makes more sense, or pi, than 8 pi over 7. Okay? So the way to go about it is to change the number of ticks, right? Now, how can I change that? So let me show you one thing, and then we go back to the question. So one of the things you can do is to go to the figure editor and do it manually if you want, or find the name of that property and then change it in your code. So one thing you can do is you click on this edit plot, and then double click here to bring out the figure editor. Okay? Here, property inspector. And this will show you lots of properties that you can change using the set command for this figure. You can do tons of things here, and I'll show you them. So you can manually change them, or you can change them through your code. Let me show you the manual one, because that could be quite interesting, and then we talk about the code itself. For example, let's say you want to, what? You want to print this, right? Or you want to add this picture to your Word document for your report. How would you add this picture to your Word document? So you go to somewhere, and then you create a new Word document. Let me show you. So here, new Word document. And then I want to copy this picture and put it on the Word document for printing later. I don't want to print this only, I want to add it as a portion of my report. So some of you might say, well, I use the snipping tool. Well, fine, if you use the snipping tool, what's the problem? When you do the snipping tool and take a snapshot of this, well, now you see the picture background is white while these boundaries of the picture are gray. And when I copy this and take it to the Word document, it might not be super nice to look, right? You would rather everything be white. This gray and white, I'm not sure, too interesting. The other thing is, if you look at these ticks, the values, they might be small. And like when you print this, they might be quite small, and especially if you don't have too much room, so you have to put several pictures on the same height in your, so you have to resize this and make it even smaller. Look now. So you have another picture to go here, and another, let's say 4 pictures. Now your ticks are so small that the viewer might not be even willing to look at them and say, hey, what the heck are these ticks? Could you make them a little bit bigger and darker so that I see what you're talking about? Can you change that? Yes. So I'll show you those, but before that, let me show you one more thing. If you want to skip this background gray, there are two ways to get around it without modifying it to white. One is you go under Edit and say Copy Figure. If you do that and come and paste, oh, let me do it one more time. Edit, Copy Figure. Here. Now it only copies the figure, not the surrounding color of it. The bad thing is it gives you lots of extra white space on the sides. Okay, so if you have some text here, this white is going to take over that if you make it wrap text in front of, and if you make it behind so that they don't show themselves. So you can type something here, let's say, right? So now this is not going to take over that and occlude it basically. But then, you know, moving the pictures that are behind the text is not always easy when you have a crowded Word document. And I told you, if you make it in front, now, wait. Ideally, it should take over that, but no, it doesn't. Which is an interesting thing. Maybe it's because I brought it after I type my text. Let's see, or maybe, no, that's good. So that's good. I like it. At least it does not, even if it's over the text, these extra boundaries that MATLAB gives you, they are not really a part of the picture. They are not occluding the text. So that's good. Or you can save this plot under Save As. And instead of saving it as a MATLAB figure.fig, which you cannot open in Microsoft Word, you cannot open in Paint, in Photoshop or anything, a photo editor basically. Instead of saving it as a MATLAB file, you save it as a picture file, like .ping if you don't want compression, or if you wanted a smaller file size, .jpeg, .bitmap, and so on, .tiff. I always recommend ping formats, but you save it as a ping image, correct? And then go to your Word document and insert it here as a picture. Okay, so this way also that gray boundary that you just saw should not come and bug you. Now, if you make this in front of the text and go, it will occlude the text, right? So to me, if you really want to bring a picture from MATLAB to Word, it's better to directly go from Edit Copy Figure than to store it as a regular picture. Or as I said, you might simply use a snipping tool, no problem, but change this background color of gray into white. How? As I said, bring this editor by clicking on this edit plot, double click anywhere to open it up. Now you have the option to change lots of things here. So if I double click here, now it should allow me to change the color of this figure, okay? So here I have the window appearance, and if I expand it, then this color element here is the color of background, and it's gray right now. I can go and make it white here. Now, even if I use a snipping tool, I'm good because everything is white, right? What else? They told me, hey, these ticks here on the X or Y axis, they are not really good. Could you change that? Make them a little bit darker font, bold font, and bigger in size? Yes, I just click on this text, these ticks, and it brings them for me. It says, hey, X ticks are at 0, 1, 2, and so on. They're 8 by 1, right? And if I expand it, now they allow me to modify a bunch of things. Like what? Like, for example, let's find the size. And here are the labels, X label, Y label, but I should be able to, you see XZ tick mode. So that's the mode is auto. I can say I want it to be manual, right? You see, I can make it manual. And these are the location of those ticks. I can change. If the default is 8, I can make it 5 if I want, by simply just getting rid of some of these or adding some of these, correct? Some to them, but again, as I said, my goal is to change the X label, Y label, and the size of these ticks in terms of font. So here, I clicked on the font size. Let me do it one more time so we can see. So I clicked on this text Y, or these numbers. Let's see, where's this guy? And it brings the font size for me. And instead of 10, I may choose to make it 16. And now all the text is going to go to 16, right? So I can change the font size and make it bold font or non-bold. Okay, so I have the control over that here. There we go. I can even change the type of the text and so on. Make it italic or anything I want. So you see, I clearly have the control over that. Now let's go back to this X ticks. Okay. See if I can bring the X ticks. That was the font, fine ticks. So you see, X ticks, I messed up with them. I can go back and fix it, right? I added some stuff that I shouldn't be adding, and I can delete them. So I made it 5 now, correct? So now if I go ahead and change them to the numbers I wanted, I should be fine, right? Let me go back here. And instead of these locations, column 2, so on and so forth, right? So I say 1, 2, and 3, and 4, and 5. And then the values for them are 0, pi over 2, pi, 3 pi over 2. Of course, you have to make sure it's 3 times pi, and then 2 pi. Correct? Now, whether they exactly correspond to those numbers, no, because I said the numbers that I want correspond to numbers 0, 1, and so on. So you have to make sure this correspondence here. What are the location of the ticks and what are the labels of the ticks? So I say the locations are also what? At 0, pi over 2, pi, 3 times pi over 2, and 2 pi. So you need to make sure the locations also are correct. Now this is what you want. Okay, and now this is probably what you want to copy in your report. It's a lot better. If I copy that, take it to a Word document, resize it, and so on, it should not cause any problem. Even if I make it smaller, they're probably still big enough for me to read them. And if not, I can go back and make them larger, right? So this property editor window can allow you change all of these properties of this figure, the position of it, for example. Where do I want this picture to be positioned? Well, it's at 141, 1280, and 607. And if you look at these values, are left bottom width height, which means what? If you have so many pixels on this monitor, the X and Y positions are 1 pixel and 41 pixel for the bottom left corner. And then the width of that is 1280 pixels, and the height of that is 607, okay? And if I want, I can change that. Say, well, I only want maybe 800 pixels, and for this, I only want 400 pixels. Right? Now you can change the size of this picture too. So by changing or whether you want it to be able to resize itself or do any clipping or anything. Okay, so you are allowing it whether it can do it or not. What's the appearance of that? Correct? Where are the ticks? Where are the font size and everything? Good. So these are those important things that you want to change. Now, going back to my code and answering the question before I go back to the rest of the picture. So here, remember, when I did the plot, I had a big problem. What was the problem? The problem was, if you remember, let me do some Control-Z and put it back to what it was. This is what I had. I wanted 5 ticks only from 0 to 2 pi. And originally I had 8 picks by default. So from the 6th pick to 8th pick, it started repeating itself. And I said, well, what should I do? Not only you have to change the labels for the ticks, you have to change the number of them and the location of them. Okay, so it's not just changing the labels, you need another set command, where in this set command, you say the current graphic object I have, which is this window that is open, change the X ticks for it, also to this vector of 0 pi over 2 pi, 3 pi over 2, and 2 pi. Or you can say it goes from 0 with increment of pi over 2 all the way to 2 pi. That's the same thing. So first, set the location of them and the number of them. Here, the number is 5. This array only has 5 elements. These are where the ticks should appear. Now, the title of them, the label of them, are these text values. As you see, there is a difference between this 2 pi and this 2 pi. This 2 pi is an actual number, actual location. This is a pure text. And that's why when I combine these numbers, I need a bracket, or no bracket in this case, because I'm using column operator. So this is a regular array. This is an array of text values, which we call a cell array. So now if I do this, I initially said here in this first line, I only have 5 ticks. This is the location for them. Now, what's the text you put at each one of them? Those texts that you see over there. And there we go. Yes? So you see clearly that I can change the location of x ticks, y ticks, z ticks, and so on. And by the way, here I use the command GCA. If you want to know more about this command, just type in GCA, and that will give you more information on GCA, okay? It's the current axis that is open, right? That's the current axis that is open. You can use the set command to set up a bunch of things for it, either using the command set, or you can use the dot operator because these are like a structure. So you can also say axis.font size. This way you can change the font size of this GCA. Or as I said, you can use the command font size. So you can come here and say set GCA and what? Font size and 12. Set the font size of this guy to 12, or if it's not big enough, 16. Now look, now you should get bigger font size. Yes? Or as I said, you can get the handle of this picture using the command GCA. So you say, my picture handle, this is equal to GCA, get the handle of it, and then say, let's just call it picture handle. This picture handle dot font size is equal to 16. Okay, so you either use lines 10 and 11 or use line what? 12. They do the same thing. Use the dot operator because this is a structure. We go look at the structure lecture for the structures, or use the command set. That should do the same thing. Okay, so I can change the font size. I can do so many other things. You see the tick length, the Y limit, the tick direction, and so on. There are so many nice things that you can do. Okay, there are so many nice things that you can do. So for example, remember the position? I can do the position command too. Here, instead of saying the open it one more time. Instead of saying this, I can use now the command position. Correct? And then use this 4x1 vector. It was 141 and then 1280 and then 607.33. Correct? This is the bottom left corner. That's the width. That's the height. This is kind of similar to maximize it. If I don't want to maximize it, then I say 1,000 pixels and maybe what, 500 pixels. Now it's not as big, correct? Now here, it did not like it, I assume. Seems like it gave me an error or something. Let's run it one more time. Over here, I don't have anything yet. Okay, it runs it, but this does not work as expected. So you have to make sure you're using, and that's why I'm not editing my videos, okay? I can go exactly fix it and then show you the nice fixed version, but that does not help you too much. It's important that we create these errors, you see what can go wrong, how to fix the errors, right? So here I have everything good. Now I click here, go to this editor, go to the position, and try to figure out what is wrong here. So that's called the position. Seems very fine to me, but X, Y, width, and height in pixels. Okay, right. Now when I come here and try to do it, apparently it did not like this command, okay? And again, here I know it, but I want you to see how I'm debugging it. So I say set GCA position MATLAB, okay? So always try to debug by Google search and find the roots of the problem. Okay, so you see font name, font size, everything. You can change all of that. These are all of those properties I showed you. Font units, ticks, rulers, we'll talk about them. Grid, we'll talk about grid as well. Labels, multiple plots, position. So you have an outer position, inner position, position, and so on. Correct? It is a 4-element. And if you look at these numbers here, you see they are between 0 to 1. Okay? They are between 0 to 1. They are not huge numbers. So maybe one reason that my code is messed up here is these numbers have to be converted into something, maybe divided by 1280 or something. Now let's see. There we go. Okay, although it's not really what I wanted, but it is not giving me a blank picture. Okay, so I might need to change something, and I will, right? But that's okay. At least I'm getting something that makes any sense, right? There we go. So it is very important then it's quite interesting. You understand what is going on, search the appropriate help for it, and try to fix it. Okay, so now what about the background color? You can change that as well. As I said, you just need to find which property it was, correct? And you can find it either in this help by looking into colors, which was here. And we also need to talk about alpha, and so on. But this is the background color. Okay, so this is the background color. By the way, these are RGB values for some of the stuff that you might need. So all you need is to just say color. So now if I go back here and here say set GCA and color, and then use white, which is all ones, by the way, if you want to know, or you can use W for white. Now this is all white. Now let's see. It did not change it to white as I expected, or maybe, well, 111. Let's just use W. No. Let's use a different color, see if it makes any changes. Because clearly this one didn't. So that's the color of what you have is the color of here, not because that's your axis. This is the figure. Okay, this is the figure. You have to change the color of the figure, not the color of the axis. So when you say GCA, which is the current graphic axis, you are changing the color of the background of this, not that. So instead of GCA, you need what? There we go, GCF, correct? because there is another command in MATLAB called GCF, which is the current open figure, not axis. And that also has color, has all sorts of properties of its own. So the one thing that you need to change is come back to GCF and make this guy white. Okay, so that's the difference between GCA and GCF, the axis versus the figure. You see? Now you got it. So current open axis, which is this plot, versus the whole figure, because the whole figure can have more than one of these plots in it. Really? Yes, I'll show you using the command subplot. You can have several of these plots in the same window. And how do I know I'm talking about the properties of the window or the properties of the axis? Then I have to use either GCA or GCF, okay? So these are some of the interesting things that you might have. One of the other things I want to mention is the direction of the ticks. Sometimes the ticks that you have on the X or Y axis, you want the ticks to be backwards. What do I mean by that? So look here. My ticks are going 0, pi over 2, pi, 3 pi over 2, and 2 pi, correct? Sometimes I want my axis to start with big numbers on the X on the left side, and then as it goes to the right side, the numbers go smaller. So I want to reverse the direction of the ticks. I start with big numbers on the left, go to small numbers on the right for the visualizations. Can I reverse the order of the ticks with the values? Yes. What I need is a command called set, not the new command, but instead of xtick or xtick label, I need xtick, and it should be direction. And then it should be, I guess, reverse, but we can always check it. So if we go back to that figure, I'll show you that. So here we go, double click. And let's go to the ticks so I can show you what I mean by that. Ticks, let's find it. You can double click here, so it brings us to ticks. And you can search it here too. So X label mode should give me here tick direction. Tick direction. In, out, both. And it should allow me to change X and Y and Z separately. Okay, you can also rotate the direction of the tick. So here Y, the vertical axis is upright, is rotated 90 degrees. But if I want, I can change that rotation as well and make it horizontal. So here I have the tick direction, which is in and out and both. X tick mode. Direction mode manual. Okay, and yes, I should be able to get X tick dir. No? Okay, but I'm sure we have it. So X tick direction. Anytime you forgot the syntax of something, make sure to look it up, okay? There is no shame in not remembering everything. Nobody can remember everything. So it says tick direction out means backwards for all of them. Is there any way that you can do it for one axis only? Then you have to first get that axis x-axis and then say tick direction for that is out. So you see, in the past, I remember when I wanted to do it, I can do it directly using something like this. Not anymore. You have to now look at the x-axis specifically by getting it, get the handle of the picture, give it a name, look at the x-axis field in it, and then set the tick direction for it out. Out means backwards here. Okay, so you either have in or out. And I can do it because, again, as I said, if I say the tick direction here, and I say out, right? Okay, it did not like it. Probably I did a tick direction. Tick dir, not direction. Tick dir. You see, this is out. If I say in, that's the same thing, right? I don't see any reversing happening here. And that is quite interesting that it does not change anything, because it should. So let's debug it. Click on the ticks. Here, X ticks, mode. Just do it one more time. Okay. Out. No difference, because I guess I fixed them already here. Now what? Okay. No. So that did not work. Clearly. Reverse x-axis. MATLAB. Oh, no, I don't want flip. Command. Yes, X direction. That's not the tick. I want the X direction itself. That's what I was talking about. So that's what we need, not the ticks. We need this one. Okay, change the direction of the X. Now you see, I'm starting at 7, going to 0. I'm making it flipped, basically. So not the ticks, the X direction itself. If I want Y direction, then I use Y direction. Anyways, so sorry it took so long, but it's important. Let's talk about a few more things that are good. So I made this figure But now I don't like the limits I have on the X and Y axis. My X axis is going to 7, although my number is exactly at 2 pi. So I want my X axis to exactly go from 0 to 2 pi. And my y-axis, which is between negative to 1 and 1, maybe I want to extend it a little bit so that my markers are not on the boundaries of top and the bottom. Can I change the size of this window in terms of x and y limits so it can be modified? Yes. The way to go about it is the command axis. So you say axis, and then in a vector that has 4 values, you go with x min, x max, y min, and y max. And in this case, I want to go from 0x min to 2 pi x max and negative 1.1 to positive 1.1 y min and y max. Okay, and there we go. You see, now my axis limits are a little bit better, more under my control. Good. So that's the command axis. Sometimes I need to turn the grid on for better visualization. So I say grid on. And now it will turn the grid as well for me in the background. Okay, if I don't want it later, I can say grid off. But these are some of the very important commands. Now, let's talk about some other things. Like what? Sometimes you want to plot a circle, right? Many times you want to plot a circle. One way to plot a circle is to create a bunch of values for x, or theta in this case, between 0 to 2 pi, let's say 100 values. Choose a radius, choose a center, and then write the equation, parametric equation for x and y as a function of theta. So x in this case is going to be x naught plus r times cosine of theta, and y is similar equation, except it is r times sine of theta. So these are parametric equations of a circle with radius r and center at x naught and y naught. And you plot it. And let's say I just plot x and y here, no marker, nothing. No axis, no grid. Maybe grid is good. And here, maybe I call it circle. Okay, so here you get a circle. What's the problem? The problem is, although it's a circle, it doesn't look like a circle. It looks like an ellipse to me. Why is that? Because the aspect ratio is not 1 to 1. If you look, the whole height of the y-axis is 8. The whole height of the x-axis is also 8. But for some reason, it does not look like these squares are really depicted as squares. So although the heights of the x and y axis, the limits are the same, but because it uses an auto, it does not really project in it that way, and that one of the reasons is the monitor. Now, is there any way that I can force this guy to show me a real circle in the picture? Although it is, as you can see, the radii are the same, so it's not really an ellipse. But how can I make this show me a better version of a circle? The way, remember, I had the command axis. With the command axis, you might say, well, I try to play with the x min and x max, y min and y max, such that I force it to make these aspect ratios to look 1 to 1. Yes, but you have to do a bunch of trial and error to figure out exactly which numbers to show to make it one-to-one. The better way to do it is to say x's and then say square. This way, you're telling it, hey, use a one-to-one aspect ratio. And now you're going to get a nice, beautiful circle. Okay? Still, they are 8 and 8, but now the way these ratios are shown are such that when you show the circle, it looks like an actual circle. Now, what's the ratio of the height and width of these triangles? They are similar to what you have in the monitor to force it to look like a circle. Okay, so it does the calculations for you. Good. Now, let's go to the next level. What if you have more than one curve on a figure? For example, you have two plots. So here, let's say I have a circle, right? Then I also have an ellipse. So this is the circle, right? Now let's say I have an ellipse, and the ellipse has a different equation, as you know. So let's say this is x of the circle and y of the circle. And this is the plot of the circle, right? So this is the circle. Let me add something for you here. So this is the circle. Now I also want to add an ellipse. Now ellipse has two parameters, semi-minor and semi-major, and let's show them with A and B. So let's say A is 3 and B is 5. We still use the same theta that we did, but this time, and we also have some center. So x of the ellipse is, let's say, 1, and y of the center of the ellipse is -1. So the equation for x and y are like this. This is x of center plus what? This is a times cosine of theta, while y is, and by the way, I can call these different x and y. So x circle, y circle, then x ellipse, y ellipse. And I can call this x naught and y naught. And y is going to be y naught of ellipse plus b times sine theta. You see? They don't use the same coefficient. And when I do the plot, when I do this plot that I did, then on the top of this x of circle and y of circle, I also want to do plot what? X of ellipse and y of ellipse. And maybe use a different color. Maybe use red instead of blue. Fine. What's the problem here? The problem is I do plot the circle first, but then when I plot the ellipse in line to any one, what happens? The plot of the ellipse is going to replace or overwrite the plot of the circle. Look. First of all, it gave me an error. It says, what are you talking about x of ellipse? He's right, because I have not defined x ellipse and y ellipse. You see? That's the ellipse. Look at that. From here to here is 8. From here to here is 10. So this is my ellipse, and it's red. The circle is gone. Why? Because this replaced the previous one. To avoid replacing and to draw a new curve on the top of the previous one, I use the command hold on. Say, hey, hold on, don't clean that. Draw this on the top of that. Now look. Now I have two of them. You see? Now I have two of them in the same plot. And not only that, any other plots that I create from this point on let's say, that will also be on the top of the rest, if it can do it. Now here, I don't think it can because you have to do the dot operator, but it's interesting, right? Looks like an M. It keeps plotting on the top of the previous one until you say, hey, hold off. Means don't keep plotting on the top of the previous one. So whenever I say hold on one time, you don't need to each time use a new hold on. It will be on until you turn it off. Good. So this is for the sake of what? This is for the sake of plotting several graphs, several curves on the top of each other. Good. Hold on and hold off. What else? Now that you did it, you want to put some text somewhere we call legend, which tells you which one is which, because not always it's as clear. So you want to say, for example, the first one or the red one is circle, the blue one is the ellipse. You want to provide some legend here. Now you can either use this guy here to insert the legend, or from the command, you can use the command legend. And here you provide some text. How many of them? As many as the number of curves. I have 2 plots, so I need 2 texts. The first one was circle, and the second one was the ellipse. If I have more, I add more text. And now I have it, this guy here. Good. You see? And this will tell me which one is which. Now, sometimes these axes and these graphs are such that they come on the top of this legend and they kind of go over that. They occlude it. For example, all I need here is to move my ellipse a little bit to the right, correct? So let's just shift it about 2-3 units to the right, see what happens. So to do that, I make this 3. Look. You see, now this legend is occluding a portion of my curve. How can I move it? Now, in this case, it's not too bad. But when it was like this, it was not maximized. You see, it is not. Can I move it? Yes. I click here on this edit plot. I click on this legend and I drag it and put it wherever I want. Right? So that's one way to handle it. But can I do it with the code so that I don't need to go manually and change everything? Yes. When I do the command legend, I add something to it and I say location. And here I can provide some text. So if I say northeast, which is on the top right corner, that's where it was initially. But maybe I say instead, put it on northwest, correct? To put it on the top left corner. And now it should move it to this side, out of the way. Sometimes I'm not sure how my graphs would look like ahead of time. So instead of me saying southeast, southwest, so on, I say best. You decide for me where to put it so it doesn't occlude the rest of the curves. And it decides maybe in the center is better. Okay, so this is the command legend and where to put it and how to change it. Okay, what else? One other thing we have to talk about is adding elements to my picture. Let's take a look here, what I mean. So sometimes, let's say you want to add something, like what? You want to insert a line, insert a text. Can you do that? Sure. You go under insert, and then you can add a line, you can add an arrow, a text arrow, text box, rectangle, ellipse, axis, and so on. So let's say you're looking at a specific location and I want to add a small point and then write something. So maybe I add an ellipse, a small one, maybe at the center of the circle, very small one, like that, and then I go to insert text arrow, click on the text arrow, and then here I type in center of the circle, right? And then if I want, I can move the end of the arrow, I can move the beginning of the arrow, the location of the text, and so on. I can resize these guys. And I can add more informative, or I want to add a line here. Let's say from 0 to 0x and then 1, 0y and something. So can I do this extra stuff that I'm doing, adding line, adding text, and so on, manually using the insert command or a text box, correct? Can I do all of this with the command? Yes, I can do that. How? Well, there are commands for that. For example, if I want to create a text, there is the command text. And the command text will create a text for me. It adds a text in location X and Y, and then you provide the text here. So next time, maybe I go to the center of the circle and add something. So when I do this plot, legend, everything, I also go to this location and say center of the circle. Let's see. So you see, it added something here. Now you probably prefer that this text is centered with respect to points 2 and -1, not start at 2 and -1, because when the location you provide here is the beginning of the text. So maybe you bring this text, instead of starting at 2, you started at maybe 1.5, right? 1.2 and something, and a little bit above 0.2 and -1. So maybe here you add a little bit to it. And here, maybe you bring this guy down by 1 unit. And now it is shifted a little bit above that location on the center. And here, if you want, you can add the ellipse. There are commands for each and every one of them. There is command for inserting line. There is the command for inserting ellipse, text box, and so on. But I showed you the command text. And if you go down, it talks about, by the way, that's another good thing in MATLAB. When you learn about a good command like this, right? You learn something, you go all the way down and it shows you more related commands. And these are very good. One of them, for example, is annotation, where you can create a line or arrow annotation between 2 points. Okay, so we provide vector X, vector Y, and a line type, where line type could be text arrow, double arrow, arrow, and line. Okay, or if you want, you can create a rectangle, ellipse, or text box. So if you want, most of those stuff that you saw, it can all be created using the command annotation. And this is going to be really interesting, correct? Just tell it the shape of the annotation, the line type of the annotation, and so on and so forth. So here, look. You say, hey, between the X values of the 2 endpoints and the Y values of the 2 endpoints, do an annotation of a text arrow and show this string for that arrow. So one of my points is 0.3 and 0.6. The next point is 0.5 and 0.5. Draw an arrow from 0.3 and 0.6 to 0.5 and 0.5 and show a text with an arrow. Now, you might say, well, 0.3 and 0.6, right? But the point here is actually 3 and 6, 5 and 5, not 0.3 and 0.5. That's right. The X and the Y values you provide for the annotation commands do not correspond to the actual X and Y values. When you use the command text, they actually are the X and Y values you see in the graph. They are the actual X and Y values you see in the graph when you say the command text. But when you say and use the command annotation, the X and the Y that you use are ratios of the location X and Y to the overall X and the overall Y. So here it means 0.3 means location 3 out of 10. If the height of the axis is 10, also 0.6 means location 6. Okay? So these numbers that you provide in X and Y, they are only what? Ratios. Okay? And here, I'm going to show you that. So I want the text arrow that says this is the circle, and it goes from one point to another point. What are the points? The first point is, if I go back and look at my figure and get rid of this, maybe I want it to be here, that's okay. And this point is 1 in a ratio of 8. So this distance from 1 to 2 divided by 6 to negative 2 is 3 over 8. That's x, and then the y, if I put it at 0, it's going to be 0 to negative 6 over 4 to negative 6. So 6 over 10. 3 over 8, 6 over 10. Right? So here. Three over 8, 6 over 10. This is the x and the y of the beginning point. And let's say the end point is somewhere here, like at negative 1 and 2. And the ratio is 1 over 8 and 8 over 10. 1 over 8 and 8 over 10. Okay, so these are the x and y. This is the x of the 2 points. These are the y of the 2 points. Beginning point is the left point, right end point of the arrow is the right point. So now let's do it. Okay. Invalid pair. Did not like my numbers. Okay, I can always check. Why not? Does it need decimals? I'm not sure if it does. Highly unlikely. MATLAB can calculate it itself. So we'll see. No. Okay, invalid parameter values. Okay. Annotation, text arrow, X, Y, swing. Yes, I don't see any issue with that. X beginning, X end, Y beginning, Y end. 2 elements. You see here it says specify the text in normalized coordinates. Oh, I have to say string and then. Okay, I see. Good. So you have to provide string and then the text, of course. Otherwise, it doesn't know what kind of input is this is the circle. So now, there we go. Now, I guess this is good. This endpoint is not super good for some reason. Well, seems like the X is not so good, but the Y is not too bad. So the X needed to be bigger than that, apparently, and the Y is smaller than that. So there we go. So using this annotation command, you can create all of those things that you had with insert. And as I said, you can see it here. That this line type can be a bunch of different things and the shape as well. Okay, so if you wanted to create an ellipse, you just say, hey, ellipse with those dimensions, which is the center and the X and Y, or semi-minor and semi-major axis, right? So these are for all of those, the command annotation. Okay, let's go to the next topic. The next topic is, so far I created several graphs on the top of each other using legend and hold on. Sometimes you do not want each one of the axes to have several graphs on it. You want to have different axes on the same figure, each one with 1 or 2 graphs. So if you want several axes on the same figure, you have to use the command subplot. Like, for example, here, you see I did circle and ellipse on the top of each other. Instead, this is what I do. I say subplot 2, 1, and 1. On that, do the circle. Then subplot 2, 1, and 2. On that, do the ellipse. I don't want any legend because I'm doing each one of them in a separate axis. No annotation, nothing. And show it to me. Now what happens? Now, instead of both of them on the same axis, you have 2 different, these white windows, each one we call an axis. On the same overall window, we call a figure. So now I have 2 separate axes, or we call subplots, in the same window. Now, some important things here. 1, what was this 2, 1, 2 and 2, 1, 1 that I did? The first 2 numbers will tell me how many axes are in each direction. This would tell me I have 2 rows of axes or subplots and 1 column. So if I create a bunch of subplots in the form of a matrix, then this is the number of rows of that matrix, this is the number of columns. So if I say 2 and 2, it means 4 subplots, right? 2 rows and 2 columns. Look, there are 2 more here. I haven't done anything on them yet, but it is going to be a 2 by 2. So what is this third number? This third number would tell me which one of these 4, correct, you want to do something on. So let me do 4 subplots instead of 2. So this is 1, 2, then maybe on subplot 3, I multiply the x values and the y values, just for the sake of interest. Right? Now look. Yes? This is the third one. And I can add a fourth one if I want to. For the fourth one, maybe I change x and y. I make y to be x and x to be y. Yes? So clearly you see the arrangement is a 2 by 2, 2 rows, 2 columns. And when I say 1, 2, 3, 4, what's the order? This top left one is 1. Then in the same row, that's 2. Then we go to next row, that's 3, 4. If there is more rows, 5, 6. So the numbers go row-wise. First row completes, then second row is completed, third row, fourth row, fifth row, and so on. That's how the number for each subplot is determined. Good? What's the other important thing? The other important thing is this. Remember, I provided a X, Y label and a title, correct? When you have several axes or several subplots on the same figure, if you type in X label, Y label, and title under one of these subplots, it will only create the X, Y label, and title for that subplot only, not for all of them. So if I want to add something like that, X, Y, and circle, for this one, I have to type those 3 commands again under this whole thing, right? So for example, remember this one was the circle, right? So I have to add them here. Then here I go and say ellipse. Then here for the third one, I do something else. And here I do something else, correct? This is called like test shape 1. And maybe this call it test shape 2. Something like that. Okay, so each one of them has their own XY label, title, and everything. Okay, and that is very, very important, that they are individual things. Good. Let's talk about one more thing, and then I guess we are okay. Sometimes you have more than one window open, so you don't have 1 or 2 graphs. By the way, each one of the subplots now can have several graphs on it. So if I want, I can go to this first one. Not only I do circle, I also do what? The ellipse. And then say circle and ellipse. Here. Right? You see? And by the way, this hold on only belongs to this subplot. The other subplots, if you want to turn something on in them, hold on or hold off, you have to do it separately. So only the graphs in this subplot will be on the top of each other, not the other ones. Right? So each one of them, you can treat it completely like an independent entity. Now, sometimes you have more than one window. Sometimes you don't want to squeeze everything into one single window with so many graphs and so many subplots. Maybe you want the first 2 axes to be in one window to make them bigger, and the next 2 to be in another window. Can you do that? Yes. Every time you want to create a new window, a blank window on which you can add as many axes as you want, use the command figure. So maybe I say figure here, And then in an arrangement of 2 by 1 by 2 by 1, I add circle and ellipse, right? But then in a separate window, you see I'm creating a new blank window again using the command figure. This time in an arrangement of 1 by 2, I do these test shapes. So now look, when I do that, now I have 2 windows, each one with their own axis and with their own arrangement. Okay, and by the way, each one of them has a name. One of them is figure 1, one of them is figure 2. So let's say here, at the end of everything, I decide to add something to this first subplot of figure 2. I decided I want to change something here. Maybe instead of test shape 1, I want to change something, or I want to add a graph to this. How can I do that? I say go to figure number 2, go to subplot 1 and 2 and 1, go to that first one, hold on, don't clean anything, and then plot for me x of the circle plus x of the ellipse versus y of the circle plus y of the ellipse with color green. Yes? So I'm referring to that specific figure, that specific subplot, and without cleaning anything, I want to add something at the end of my code. There we go. You saw that? Without affecting anything else, I went to that figure, to that subplot, and I added something. And that is important, not to affect the rest of the shapes. Okay? Good. And you can, by the way, you can name your figures anything that you want, okay? You do not need to necessarily let MATLAB call them 1 and 2. If you want, you can give them name. Maybe I want to first call my first window open figure 3 and the next one figure 10. They don't even need to be in order, 3 and 4 necessarily. So when I open them, now here is a little bit confusing, right? Why? Because when I refer to this window at the end, initially when I said I have a figure, I should have said figure 3. Here I say figure 10, and then here I refer to figure 10 to do that. So look, there we go. So now they are called figure 3 and 10 instead of figure 1 and 2. If you don't provide a number for the figures, MATLAB will, and simply use the simple command figure, MATLAB will start ordering them from 1, 2, 3, and so on. Okay, now can you give it a name to the figure? Yes, you should be able to even provide a name to that figure. Okay, how? If you remember the GCA and the GCF, they should be allowing you to provide names, correct? Can I? Well, let's find out. So this figure 3, can I give it a name? Say first. Can I do that? No. When you say figure, you expect at most MATLAB to provide a number. You cannot say figure some crazy text. Okay? But if you want, you can give a name later to that figure. Because look, when you open this, you see the names are figure 1 and 2, right? Now, if I go here and say set GCF, this current figure that is open, and name And then original shapes. Correct? Let's see what happens. You see? Now you have added a name, a title. The number of the figure is still 1, but now it has some extra name to it. Excuse me. So that's how you go about naming figures. Okay, so I guess I told you lots and lots of information in one video on plot, regular plot command. So now let's look at a few more things about other 2D plots. And finally, finishing the lecture because it went too long. So let's go and again make life very simple from the beginning and see what we can do. So sometimes you want to plot one thing versus the other, but the scaling of the x's, you don't want it to be linear. Remember here when we said x goes from 0 to 10 with some increment, plot x versus y, and so on. Correct. Then the scale here is linear. I mean, the distance between 8 to 10 is the same as 6 to 8, 4 to 6, 2 to 4, 0 to 2, linearly spaced. Sometimes for some of the functions, it's better to use logarithmic scale. So as the number is getting bigger and bigger, the physical distance that you see on the axis between them is reduced. For what type of function? Well, I'll give you an example. For example, let's say you want to go from 0 to 10 with some increment of 0.1, and your function is like exponential of x. And you want to plot that. Now, if you do that here, let me add also the markers so that you see them better. If you look here, it looks as if the first half of the data almost are literally 0. And then from 0, you go bigger, bigger, bigger until you end up around 2 times 10 to the 4, 20,000, 22,000. Now, is that correct that this first half of my data, they're all almost 0? No. Why not? Because they are all non-zero numbers, but when you compare them against 20,000, they don't show themselves very well. I mean, if you look at the values of y, no value in y, even the first one. The first one is what? Y of 1, if you look at it, or y of, let's say, 1 to 10. If you look at them, none of them is really 0. The first one is 1, 1.1, 1.22, and all the way to 2.45. So out of the first 10 values, none of them is 0. But 1 or 2 compared to 22,000 on the graph, it doesn't show itself. It looks like 0. So when there is a huge increment or decrement in the data, as x's are getting bigger and bigger, so the function is a power function or exponential or logarithmic function, you better use logarithmic scale. And that's where, instead of a regular plot, you better use something like Semilog x. Okay, only use one of the x's. Which x's? X-axis. Which scaling used for it? Logarithmic axis, x scale. Now, does it make it any better? Of course not. made it even worse. Why? Because now you see like more than 3/4 of the data, they look like 0. Of course, because it's your y-axis that is getting bigger, not your x-axis. It's your y's that are getting crazy big. So you need to use what? Semilog y. Now, when you do that, that is quite interesting. Your function does not look like a line anymore. It looked like an exponential function anymore. It looks like a line. And it might be a little bit confusing, isn't it? It is. You expected the exponential behavior, but now you see a linear behavior. Why? Because if you look on the x-axis, you have linear scaling. On the y-axis, you have logarithmic scaling. So when y is exponential of x, you're not plotting y versus x. You're actually doing what? You're taking natural log of y, which is x, correct? It's the same as natural log of exponential of x, which is x. And what you are plotting is natural log of y, which is x itself, versus x. This is what you are plotting. Instead of plotting y versus x, where y is defined that way, now you are plotting what? Natural log of y, which is x, versus x, and of course natural log of y, which was x. X versus x is a simple line, as you can see here. So yes, now you clearly see that none of your y values is 0. They all have non-zero values. That's good. But now the behavior of the function is a little bit confusing. You kind of linearize the exponential function here. And that's what you do, of course, in nonlinear curve fitting for exponential functions. There is another option that you might try, and that's called loglog. Means use both x and y axis in logarithmic scale. And this is the best option. That's what you want. The behavior is still preserved, but now both axes are logarithmic scale, and now none of your values look as if they are 0. So to summarize it, if you have exponential functions, power functions, if you want to preserve the behavior of the original function, at the same time, you properly show the values of the points such that a bunch of them would not appear as 0, it's a good idea to use both axes in logarithmic scale and use loglog. So semi-log x and y, they're good when you want to look at some unknown parameter, for which you can look at the curve fitting lecture that I posted. Okay. Let's do one other level for you. So sometimes you have something like this. X is that, and y is exponential of negative pi times x, or pi times x. And you plot it, correct? Good. Now, you want to add x and y label. We do. And now you want to add a title. In this title, you want the criterion of the function. And fine, but if you really want this pi, right, to be written as Greek pi, and if you want this exponential to be like superscript and regular script, so this negative pi x will appear as a superscript, so it's e to negative pi x. So you want to type it as if you're typing an equation in Word to make this look nicer. Then the way to go about it is you need a little bit of change. What change? Well, first, you can make this e caret to the power. Anytime you use caret, it means superscript in a text. So now you clearly see that something is gone up. Of course, not the whole thing, it's just this parentheses. But if I do something like this, let's see here. So the negative gone up, but not the pi x. Why? Because anything that wants to be superscripted has to go inside braces. Now the whole thing will go up. Good. So to add superscript, you can use caret, and then whatever is superscript, it goes inside braces. If you want subscript, use underscore. Right? Now, in this case, you want a superscript. Fine, good. What would you do with the pi? I want this pi to not be shown as p and I. I want it to be pi really. Then I add a backslash here behind pi. It tells you this is, it tells MATLAB this is the Greek pi. Now look. Boom. If you don't want that asterisk, get rid of it. That makes it a lot more professional. Yes? So if you want Greek letters, then you have to type the name of that letter with backslash. And what are these letters? How do you type them? Again, you have this slide here. Okay, so backslash alpha, beta, gamma, delta, epsilon, and so on. And you can see them, how they're showing themselves. Also, there are other specific characters, not only Greek characters. Sometimes you want to show an arrow. Then you say backslash left arrow, backslash divide, backslash inf t means infinity, correct? Integral, right? Less than or equal, and so on. Proportional to. So there are some nice stuff that you can add to make your text a lot more professional. So here I can say backslash int means integral of that dx, right? You see? It's a lot nicer. Or something, a limit goes to infinity or so on. So these specific characters with the title command can make it a lot more pro. Good. So far we have seen a bunch of different things about the plot command. But is plot the only 2D plot in MATLAB? Of course not. There are a lot of more commands in MATLAB for 2D plots, like the bar plots, stir plots, error plots, pi plots, and the command feather for creating arrows, and so on. So let me show you a few of these. So sometimes you have a vector and you want to create a pie chart, something like Excel. So let's say you have what? Something like 5 components of something, 3 components, and you want to show the shares, right? Correct? Or the, let's say, the distribution of races within US. So you say R equals, and here you provide some percentages, like let's say 68% white, 12% African American, and then so on and so forth, correct? And you want to create a pie plot out of that. So race distribution USA by population, you can find a something like this, correct? It says white is, oh, that's 2045. Now I want current data. Come on, show me a good data. It's not bad. So 60% white, 80.5, 13.5. Where's Hispanic? Hispanic is 18.5. 13.4 is African American. So 13, 18, 60. 13, 18, 60. 60, 13, 18, and then some of that is 81, correct? So let's say 19% others, all of them. And now you want to create a pie plot of this race, correct? Let's see. Here, that's the pie plot, correct? Now, let's make sure some of my numbers are actually 100. Should be. No, it's 1.1. I said there is something wrong. Because, oh, that's 31. So those numbers don't match. Here. Okay, so that's a pie plot. Now, I show the percentages. That's good. Now, I want to say each color is what, correct? And maybe I want to use the slices to come off to make it fancier. So if I say explode, give it the option explode. Now here it doesn't like it. It used to be like that. So we can always go back and check. Because each version of MATLAB, they're changing it. You see, explode, offset, that's what they said. Oh, you should not put it in, I see, you should not put it in quotation marks. Now what? Oh, you have to say which one is coming off. I see. Okay. It's different. So you have to say which one of these four should come off. Maybe not all of them. Maybe I want the first one and the third one. So which one the one that are 1, they come off. The one that are 0, they stay. Okay, here. Okay, so the first one and the third one came off. Or if I want, I can do it differently. Say the second one and the fourth one come off. Okay, so with 1s and 0s, you tell which one to be exploded. Right? So that's about that. Now, you can also add labels to it. Okay, you can add labels and say which one is which. Again, you have to define the vector of the text that you use for each one of them in braces because it's a cell array. So you have to add labels, basically. So here, what I can add is white, African American, and then Hispanic, and then others. All right, and here go with labels. There we go. Okay, so this is a pie chart, very nice. And if you want, you can make it pi 3. There is a pi 3 option. And it make it 3D for you, but we'll talk about that later. But anyways, this is one of the charts that you have, pi. Then we have the stem plots, stair plots, bar, and so on. And bars, so here, let's say I have a bunch of X's and Y's, and I can do something similar here. Let's say X is 1 and 2 and 3 and 4. R are these numbers, and then do for me a bar of X versus Y. Okay. And then it creates a bar plot of these. And again, if I don't like these, I can provide X and Y label for it. So say X label is, for example, race or ethnicity, and Y label is total population percentage. Okay. And here, since 1, 2, 3, 4 doesn't really mean anything for those races, you can change the ticks if you want. You can change the ticks, and instead of this X label, instead of these numbers for X, you can change the ticks. So instead of 1, 2, 3, 4, you can change the ticks to be those populations. So you see here, and I can click on the ticks, and I can change them, or I can use the same commands that I showed you last time, right? Using the set X tick and X label. So here the location of the ticks are correct. The label of them, you might want to change it. Something like this. Okay. And you get a bar plot, or you can make it horizontal. You can use bar H, and so on and so forth. Rotate it. You can use stem plot. Okay. The stem plot is a little bit different than the regular plot. So here, each one of them will look like a stem with something on the top. Okay, you can use stairs plot, that they go in levels. Now here, it might not be super convenient to see, but if I change my axes, make it nicer, so I go 0 to 5, and then -1 to 1. That might show it a little bit better for you, correct? So now you see here, for first group, I have that much, second group that much, third group that much, and then fourth group. So you have stir plot, stem plot. There is one of the nice ones, it's called error plot, which not only you show the range on each one of the data, you also show a confidence interval. Error plot, of course. Okay, it's not just error, because error is the error message. So let's see if I can get this guy. Error bar. That's why it is called now error bar. So each data, each group has a range with the confidence. So you see the average of them with the confidence interval, that outside it, you can call it the outliers, or so much of confidence level 95%, 99% around the average. So you can use error bars, but there are a bunch of different types of 2D MATLAB commands that I showed you. So bar, plot, correct. And you can see them here under 2D and 3D plots. And there are even polar plots. Geographic plots, visualize data on maps. These are amazing new stuff. You can have histograms that are very nice, and vector fields, okay? And one of the 3D plots that is actually 2D contour plot we'll show you later. So maybe I want to show you one case of vector fields using the command feather or compass or quiver, which is my favorite. Maybe I show you a histogram. And finally, maybe I will show you a graphic plot to finish this topic. So one of the histograms is the command hist or histogram, which basically shows you the distribution of data in X using the number of bins or the location of the bins, which we call histogram. And we'll talk more about it when we talk about statistics and how to do it in MATLAB. But basically, if you have a bunch of data points, you can use the histogram and show the distribution of that data. So for example, here I generate a bunch of data from a random distribution. So I say X is rand n of, let's say, 10,000 data. And you know, all of these data are average 0, standard deviation 1. So they are mostly between -3 to 3. And then I say, you show me the histogram of this data with, let's say, 20 bins. Okay. And here you can see that it is almost bell-shaped because that's how the rand n function is. The closer you are to the average, you have a higher chance of showing up. The further away from the average, you have lower chance. Well, if I did rand without rand n, then the distribution would be almost uniform. You see? The data generated by the rand command come from a uniform distribution almost. The data from rand n, they come from a normal distribution. Okay, you clearly see the difference now. So that's the histogram command. So that's one of the things that is very useful in statistics, histograms. Then vector fields, there are a bunch of them. The one that is my favorite is quiver plot, which is used for vector fields. So at locations X and Y, you show vector fields by components U and V. This is very good for fluid flow, magnetic, electric fields, and so on. Optical flows for image processing. So let's say at locations of X and Y, you have vector fields like this. And then you do a quiver plot, and the quiver, so I'm not redoing this for you, but the quiver plot will show an arrow where the components of the arrow are U and V. So their magnitudes and their directions are determined by U and V. The bigger U, the bigger V, the bigger the magnitude of the arrow. And the angle of the arrow with respect to horizontal axis is determined by tangent inverse of V over U. Okay. So the components of vectors are again U and V. Where are they shown? At locations X and Y. So this command quiver is very good for showing basically vector fields, potential fields, flow motion, and so on. And finally, graphic plots, which is the new amazing thing that MATLAB added. So if you want to show something on the top of a map, now you can do, for example, the command Geo Plot. So at the latitude and longitude, then it plots a line for you and so on. So look at here. It creates a line between these 2 points given in latitude and longitude. Draw a green line for you. So the command geoplot. And to limit that, you have to use geolimits. You cannot use the command axis. So this is amazing, isn't it? Right? I can do anything that I want, and this command is very powerful for creating nice things like this. And if I want the color of it to not just be black and white like this, then I use the command geo base map color train. Now it shows it with the train. Okay, that is very nice. These are some of the commands in MATLAB that you cannot easily find in other things. Okay, so let me show you something nice using this and close this long video with something interesting. So what we will do is, let's say we do latitudes and longitude of LA and New York City, draw a line between them, and let's see what we can do. So I go here and I say lat longitude Los Angeles, and the numbers for it are these two guys, 34 and 118. Okay, they should be in degrees. So latitude, longitude. The first two are just latitudes, so you have to be careful. This is latitude, this is longitude of LA. Then we do the same thing for New York City. And this is these two numbers. Okay, and then we limit it, so it's 34 to 118. Looks a little bit weird. 40, 40, 74, 40, 74, and then 34. Really? 118 west. Okay. So that was 118 west. This is 74 west. That's a huge change. Okay, so geo limits 34 and 40. So we go maybe 33 to 41. And here, longitude, we go from, it's 74, so we go 73 and then 119. Okay. Now it's using a specific toolbox in MATLAB for geo and tries to get, there we go. Now, if we want to see a little bit better, maybe I limited a little bit more, so maybe 70 degrees and 122, and this is 31 to 43. Let's avoid this for a moment, see what it gives me. Clearly, it's using a ton of built-in commands to make it happen. Oh, that is a big mess here. Because it is showing it from Kyrgyzstan to China. So maybe these guys should be negative. No. Okay, so we go back. Longitude, Seattle, -122. Anchorage, -149. 4761. Yes, they're negative. It's the geolimit command. You have to be careful about it. It's the latitudes. This is the longitudes. Looks right to me. There we go. And now you see it is going from what? From LA to New York, and now we can add some text here. And say, for example, 5 hours flight or 6 hours flight, depending on how you do it, but correct. So LA to New York City is 6 hours flight. Now, if you want, you can add this guy back to show it with trains, make it look nicer, and with the state lines. So there are lots of plots in MATLAB in 2D that you can do. Hopefully this long lecture was useful to you, and I guess I am in the good spot to stop this and see you in my next lecture. So thank you for your attention, and I will see you in my next lecture.